Hello, my dear students and the rest of the learners. Welcome to part 9 of a 37-part series of tutorials in Computer Structured Programming Unit using C and Pascal. This is section 3 of 5 in the topic Program Structure. My name is Meme JM, or you can simply call me Emily Swap. In this tutorial, I'm going to look at the introduction to data types. Then I'll look on classification of data types, which will include the simple data types, the structured data types. And then we have the user-defined data types. Let's look at introduction to data types. A data type is the nature of value to be taken by a memory location. It is what a computer operates on. Data types are representations of data which are stored in the memory for processing. It specifies the values a variable may assume. A data type is therefore a set of values and a set of operations on those values. Knowledge of the data type of an item, that is a variable or value, enables the compiler to correctly specify operations on that item. Data type defines a variable in such a way that it identifies or defines a range of values which the variable is capable of storing, and it also defines a set of operations that are permissible to be performed on variables of that type. It is a classification identifying one of various types of data. That is, it determines the possible values for that type, the operations that can be done on values of that type, the meaning of the data, and the way the values of that type can be stored. Objects of a data type can either be variables or constants. Data types of an entity indicates the meaning, the constraints, the possible values, the operations, the functions, and the mode of storing associated with it. Let's look at classification of data types. The three main classifications of data types used in programming are: number one, the simple, or what we call primitive, standard, or scalar data types. Number two is what we call the structured data types, also referred to as non-primitive, composite, or derived. Number three is what we call the user-defined data types. Let's look at simple data types. These are the data types that are provided by the programming language built-in support. They are directly manipulated by the commands of the programming language. Examples of such data types in Pascal include short int, byte, integer, long int, real, char, string, boolean. In Pascal, they include short int, byte, integer, long int, real, char for character, string, and boolean. In C programming, they include short int, unsigned short, int, unsigned int, long int, unsigned long, float, double, long double, char, bool. The C data types, float, double, and long double, are all classified as data type real in Pascal. I repeat, the C data types float, double, and long double are all classified as data type real in Pascal. My dear students and the rest of the learners, remember in my previous presentations in this series, I stated that real are numbers that have decimal points or fractional parts. And therefore, in Pascal, I said they are simply called real. But in C, they include float, double, and long double. What's the difference? The difference is the size of the number or value that a memory location can accommodate. How many decimal points can float, double, or long double include or contain? So, long double contains a higher number, while float contains less value or less numbers in terms of size of the number. Long double can accommodate a higher number than the float. A string is made up of a collection of characters, and it's usually declared using data type string in Pascal or as an array of characters in C or in Pascal. Integers is a sequence of digits without a decimal point or exponent and has an optional sign prefix. In other words, integers are simply whole numbers, numbers without fractional part or without decimal point. And they can be accompanied with a negative sign or a positive sign. For example, -2, +2, or just 2, 150, etc., just as I explained in the previous parts in this series. The main rules for representing integers are, number one, they should not have commas in between. Number two, the value should not exceed the specified minimum or maximum for that data type. Number three, spaces should not be put between digits. Real or floating point data types are the data types that have a fractional part represented by a decimal point, an exponent, or both with an optional sign prefix. A floating point number has two exponents, the mantissa, m, and the exponent, x. The base of the exponent in the decimal system is usually 10, 2 base 10, 10. The mantissa and the exponent of the floating point number are separated with an e. For example, if you have a figure like 0.00001257, you can have it or you can write it as 1.257 exponent -5. In other words, if you count the number of decimal places or decimal points, if you count them from here, we have 1, 2, 3, 4, 5, 6, 7, 8. However, when we are reading in the fractional part, we begin on the other side. So we begin from 7, 7, 5, 2, 1, 0, 0, 0, 0. So you read in reverse. And therefore, in that case, when you want to use the exponent, you get the whole number or the number which does not have the zeros. In other words, you count, or you pick some of the numbers within the fractional part. For example, 1.257, 1.257. Then, in this sense, it's supposed to be raised to negative what? So we have from the decimal point, if you have decimal point here, like 1.257, then you count the number of decimal places towards point, or towards the decimal point. So you count the number of figures towards the decimal point. For example, if you have your decimal point here, then you count your figures. You count your figures as 1, 2, 3, 4, 5. I repeat, if you want to place your decimal point here, you want to write your number, the mantis and the exponent, commencing at this point, like 1 point. So if you put a point here and then read it as 1.257, because this is a fractional part, then it means that you can replace these other figures here using an exponent. So how do you know? How do you know the value for your exponent? So in other words, it's supposed to be to power what? Because it is less than a 0, of course, that will be negative. And therefore, you read it as 1.257 raised to power negative 1, 2, 3, 4, 5. So power negative 5 is what we represent as this section, exponent negative 5. Exponent is power what? So 1.257 e negative 5, meaning it is 1.257 raised to power negative 5. To power negative 5. Let's now proceed, my dear students and the rest of the learners. If you have 1, 2, 5, in other words, if you have a number like 12,000 or 125,000, 125,000, 125,700. If you are to write it or write it using exponents, then what would you do? If you, for example, you place your decimal point here, if this is where you want to place your decimal point, remember, this figure is above 0. It's not negative. It's not a fraction. This is a whole number. Well, 125,700. So if you wanted to present it using an exponent, for example, you can place, if you want to place your decimal point here, then you count the figures from this point towards your right. And therefore, if you want to place your decimal point here, then you would have 1, 2, 3, 4, 5. And therefore, you can write this number or this figure as 1.257. 1.257 raised to power what? Raised to power 1, 2, 3, 4, 5. So write it as 1.257 e for exponent plus 5. Plus 5. This other one was negative 5. So this is positive 5. Listen to me. It is 1.257 e positive 5, meaning if you are to read this part, it is raised to power 5, raised to power 5, 5, 5. Any number that does not have a negative sign, if, for example, you say 1, you can write it as positive 1. 10, it is positive 10. And therefore, this means you are raising 1.25 to power 5, power positive 5, power positive 5. So it is 1.257 e positive 5. The main rules for valid real data types are: 1, should never start with a decimal point. 2, commas are not allowed. 3, a digit must be present on each side of the decimal point. Number 4, either a decimal point or an exponent must be present. A character is any single element that can be typed through the keyboard, and it must be enclosed in single quotes to separate it from other data types. Some examples include A, period, quotes, 1, 7, asterisk. So anything enclosed in single quotes, like A enclosed in single quotes, period enclosed in single quotes, including 7. We know ordinarily that 7 is a number, but when it is enclosed in single quotes, it becomes a character, an ordinary character. It has no difference with A enclosed in the quotes. The following is a summary table for these data types in Pascal. So this table indicates various data types and the size, the maximum value each type can hold, and the maximum value, the minimum value and maximum value. If, for example, you are to use short int, it will accommodate only 1 byte, its size 1, a single byte, meaning it can only accommodate a value in between negative 128 to 127. Anything beyond 127 or anything less than 128 cannot be accommodated. So if you have to accommodate a higher number more than short int, then you use byte. It is also it's 1 byte, but its minimum value range between 0 and maximum of 255. So you cannot use byte to accommodate a negative value, a negative figure. Nor can you use it to accommodate a number which is beyond 255. So if you have to use a higher, if you have to operate with a higher value than that, you use integer. So the size of integer is 2 bytes. 2 bytes. 2 bytes. That can hold, can accommodate minimum value of negative 32,765 and the maximum of positive 32,767. So that is a little bit higher. Now, if you have to use numbers with decimal points, real is of size 6 bytes. So it can accommodate a minimum of negative or a minimum number of negative 2.97 raised to power negative 39. In other words, it can accommodate values below 0 up to 39, size 39. In other words, let me put it properly. Real can accommodate a minimum value of 2.97 raised to power negative 39. You can imagine, my dear students and the rest of the learners, how small this data type can accommodate. How small number this data type can accommodate? It can accommodate a very, 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 very minute number, fractional part, very big fraction, very big fraction size or size of the fraction, up to a maximum of 1.7 raised to power 38. So it can accommodate a maximum of 1.7 raised to power 8, 10 to power 8. Let me rephrase it in another way. 1.7 e positive 8 means it can accommodate a maximum value of 1.7 times 10 to power positive 8. 1.7 times 10 to power 8. For the minimum value, the real can accommodate 2.97 raised to 10 or times 10 to power 39, negative 39. 2.97 raised to or times 10 to power negative 39. Let me make that repeat. Real can accommodate a minimum of 2.97 times 10 to power negative 39 all the way to a maximum value of 1.7 times 10 to power positive 38 or to power 38. Boolean is size 1. It can accommodate minimum value of 0 and maximum value of 1. Not more than that, not less than that. Long int is of size 4 bytes. It can accommodate this value being negative 2,147,483,648 and maximum value of 2,147,483,647. My dear students and the rest of the learners, if you want your memory locations to be set aside in Pascal that can accommodate such huge numbers, that can accommodate such huge numbers, then use long int. But never use a big memory or never use a data type that can accommodate huge numbers, yet you not use them because you waste the memory. Our character in Pascal is of size 1 byte. It can accommodate a minimum value of 0 and a maximum value of 5. Therefore, my dear students, the rest of the learners, you must always think very carefully when you are deciding the data type to apply. Think about the sizes of the data that you are going to accommodate. That will tell you, it will tell you the data type that you are going to use. Then in C, we have the following. We have char or side character. It has size 1. It can accommodate a minimum of 1 minus 128 to a maximum of 127. And side char is size 1. It can accommodate a minimum value of 0 and maximum of 255. Int or side int is of size 4 bytes. It can accommodate negative 2,147,483,614 and the maximum value of 2,147,483,647. Unsigned int is of size 4, but it does not accommodate any minimum in a negative value. So the minimum value is 0 and maximum value is 4,294,097,295. Short int is of size 2 bytes. It can accommodate values ranging between negative 2,768 to 2,767. If you have to use unsigned short int, you should note that it is of size 2 bytes. It can only accommodate a minimum value of 0 at a maximum value of 65,535. So you can't use unsigned short int for negative numbers. Long int or signed long int is of size 4 bytes. It can accommodate values similar to int or signed int. Int or signed int. Unsigned long int is of size 4 bytes. It can accommodate a minimum value of 0 and a maximum value similar to unsigned int. Similar to unsigned int. So unsigned long int and unsigned int can accommodate same size of data. Float is of size 4 bytes. It can accommodate minimum value of 3.4 times 10 to power negative 38. That is 3.4 exponent negative 38 to a maximum value of 3.4 times 10 to power 38, or simply 3.4 e positive 38. Double is of size 8 bytes. It can accommodate minimum value of 1.7 raised to times 10 to power negative 308. Very small value, very small value. All the way to a maximum of 1.7 times 10 raised to power 308. 1.7 e, that is exponent e positive 308, meaning it is 1.7 times 10 raised to power 308. Long double is size 8 bytes. It accommodates values similar to, it accommodates values, or let me put it properly, double is 8 bytes size. It can accommodate 1.7 times 10 to power negative 308, and maximum of 1.7 times 10 to power 308. That accommodates values equal to or similar to long double. And lastly, bool is size 1. It accommodates minimum of false, that is 0, or true, which is 1. My dear students and the rest of the learners, always think of your data type in terms of the size of value that it is going to be accommodating, because the data type you use tells the compiler or the interpreter the amount of memory that should be set aside to accommodate your values. So if you assign memory locations that store huge values, and then you store very small numbers in it, you will waste the memory. So for the sake of good memory utilization, always assign data type that accommodates the size of values that you are going to use. Don't assign very small memories by allocating data types that allow very small memories, yet you know very well that your numbers that you're going to use will be bigger or higher. So always think carefully so that you avoid wasting of those memory. It's a very important resource. We move to structured data types. These are data types that are created by grouping the basic or simple data types together to form new data types, such as arrays, records or structs, pointers, sets, and files. These ones we are going to discuss in depth in my next part or in my next series of presentations that will be dealing with the data. They are the data types that cannot be manipulated by language commands. They have to be processed using a combination of several instructions put together in the form of a program segment. You can get more information about these data types from the data structures videos from part 22 to that 3 from this same channel, MLSwap ICT. Before I conclude this presentation, let me take you backwards a little bit so that we are able to do a smaller recap on data types, especially on this part of the exponent, how we use the exponent. Because it usually confuses many students. So, I said a floating point number has two exponents. A floating point number is the number that has the decimal fraction. Floating point number refers mostly to the fractional part, or a number that contains what we call the mantissa and the exponent. The base of the exponent in the decimal system is 10. The mantissa and exponent of the floating point number are separated with an e. For example, 0.00001257 can be written as 1.257 raised to power. You know, I have been saying raised to power 5, or some people say this statement reads as 1.257 raised to power -5. That's how people read it. And anybody can make that kind of an error. And that error, I want to rectify. I want to clarify very well that when we are using E, it will always be times 10 raised to power times 10 raised to power. Get it very clear, my dear students and the rest of the learners. Whenever you have an E, the exponent, always remember it is base 10 or 10 raised to power. Raised to power what? Raised to power -5. That means raised to power -5. So I repeat, whenever you come across E, remember, it is 10 raised to power. That power can either be negative power or positive power. In our case here, it is 1.257 times 10 raised to power -5 times 10 raised to power -5. Good. If you have 125,700 and you want to make use of exponent, you want to make use of E, then if you want to place your decimal point here, then you raise your value to power 10 or 10 to power something. You count the number of figures. I said, if you place your decimal point here, then it will be 1, 2, 3, 4, 5. Therefore, it will read as 1.257 times 10 raised to power +5 times 10 raised to power +5. Whenever a number is positive, you don't need to put putting the positive sign. So it is 1.257 times 10 raised to the power 5 times 10 raised to the power 5. That's a correction I wanted to make, my dear students, so that you can be able to internalize what we mean with an exponent. And with that, my dear students and the rest of the learners, we come to the end of this section, which is section 3 of 5. But before that, is going to also inform you that when we talk about the user-defined data types, they are of the following types: subranges and enumerated lists. Subranges and enumerated lists. Defining new data types is usually done using the reserved word type in Pascal, while type def and enum can be used in C. You can get more information about these data types from the data structures videos from part 22 to 33 from this same channel, MNSWAP IC. Congratulations, my dear students, for coming to the end of section 3. You can now continue to section 4 of 5 in this topic in the next part of presentation in this series. Congratulations for learning section 3 of 5 of the topic, program structure. You can also access section 1 to 5 of this topic, other topics in computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on MNSWAP ICT YouTube channel below this video. You can also visit MNSWAP Life Skills YouTube channel for free life skills, motivational and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part for the next presentation. God bless.